Assalamualaikum warahmatullahi wabarakatuh. My name is Abuza bin Zahari and my metric number is AA230727. And today me and my group will be presenting about the food chemical in industry related to lemon. So I will explain more about the acid and base related to the lemon. So the sour taste of lemon is caused by the presence of organic acid. The major acid in lemon is citric acid, which contains around 5 to 6% of the lemon juice. Other acids are also present, although in much lower concentration than citric acid. Malic acid is one of these that present around 10% the concentration of citric acid. Lemon also contains high level of vitamin C, that which also known as ascorbic acid. The levels in lemons are around 50 mg per 100 gram, on a par with oranges and around double the amount of limes. Vitamin C deficiency can lead to scurvy, a disease that causes loss of teeth, jaundice, and eventually death. In the 70s, all British ships were required to provide a lemon juice ration to seamen to guard against the disease.
Next, for the chemical bonding, citric acid. The formula is C6H8NO7. The structure is indicate covalent bonds between carbon, oxygen, and hydrogen atoms. The covalent bond is involved the sharing of electron between these atoms. And as we got malic acid. Their formula is C4H6SO5. The chemical formula is not explicitly provided, but as an alpha hydroxy acid, it also involves covalent bonds between carbon, hydrogen, and oxygen atoms. And last but not least, ascorbic acid, or we known as vitamin C. Their formula is C6H8NO6. It's a water-soluble compound with a chemical structure that include covalent bond between carbon, hydrogen, oxygen, and that's all. The covalent nature of these bonds allow for the sharing electrons between the atom organic compounds, and the covalent bonding is common where atoms share electron to achieve their stable configuration. Okay. In organic compound, covalent bonding is common where atoms share electron to achieve a stable electron configuration.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel bin Abdul Halim and my metric number is AA231026. And moving on to continue on the next criteria, and it's a fundamental of the lemons. So we're gonna sum up all the fundamentals that we have got, and the first fundamental that we got is the atomic structure, and the second is the elements. Moving on to the molecules, the chemical reaction, pH and the value of the pH, and the acidity, and the solution of the chemistry, and also the organic chemistry, and for the energy of the changes, and last but not least is the thermodynamics. So we're gonna moving on to all these fundamentals that we have got. So for the first is the atomic structure. So the atoms are the smallest units, as we all know, as an element that retain the chemical properties of that element. So the atomic structures includes a nucleus containing protons and neutrons, surrounded by electrons in energy levels or shells. So that's the basic the atomic structure. Then moving on to the elements. So basically the elements are a substance made up of only one type of atoms. Like for example, lemons contain various elements such as hydrogen, carbons, oxygen, nitrogen, phosphorus, sulfur, and others. These elements combine to form a molecule that is specific for a lemon. So moving on to the molecules. So basically molecules are formed when two or more atoms chemically bond together to perform a molecules. For instance, in lemons, molecules like water, H2O, citric acid C6H8O7, and that is citric acid, and various flavor compounds contribute the overall composition and taste. So, moving on to the chemical reaction. So, basically, for the chemical reaction for a lemon, the chemical reaction involves the breaking and forming of chemical bonds. For example, the citric acid in lemons can undergo reaction. This is for our research, mostly from the lemons is contain the citric acid. So this citric acid is influencing the taste and the acidity of the fruit. So moving on to the value of the pH and the acidity. So lemons are known for their sour taste, which is attribute to citric acid. The pH scale is a measure of the acidity or alkalinity, which means the lower of the pH of the 7 is basically a acid, and the greater of the value of the pH is a defined as the alkaline. So, and lemons have a low pH due to the presence of the citric acid. This means that the value of the pH is lower than the 7. So basically, for this, as we know, the value of pH below 7 is pictured as a acid. So this lemon is present as presents as a of the citric acid. So moving on to the solution of the fundamental solution for a lemon. So the solution chemistry in a lemon juice can be considered a solution, with water being the solvent and various solutes dissolved in it. So understanding the properties of the solution in the fundamental in chemistry, where lemon juice is combined with a water that is a H2O, combined with the lemons means the other solution may combine it as a property of the solution in the fundamental. So moving on to the organic, our next fundamental in the lemon, the organic of the chemistry. So many compounds found in the lemons, including the citric acid, like we have mentioned before, are the organic compounds. Organic chemistry studies the structure, the properties, reaction, and the synthesis of the organic compounds. This also includes the inside of the organic compounds, where we can find the properties and the reaction. Every base has a reaction, alright. So moving on to the chemical bondings. As we know, in the chemical bonding, everything has its bondings. So for a lemon, the atoms in lemons are held together by chemical bonds. For a lemon, it's defined as the covalent bond are common in organic compounds, where electrons are shared between the atoms. So the next one is the energy of the changes, or in the lemons, the fundamental. So chemical reaction in a lemons involve energy changes. For example, when glucose, which is a energy, is broken down during cellular respiration, energy will be released. So for the next one is thermodynamics, the last one of the fundamental of a lemon. Thermodynamics deals with the transfer of energy in chemical process. Understanding how energy is involved in process occurring in lemons part of the broader study of the thermodynamics. Understanding the fundamental of the lemons can learn ourselves about how is the basic of the fundamental of the lemon, how it's conduct. So that's all for me. So thank you.